Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Acid-catalyzed dehydration of tertiary alcohols proceeds via E1 mechanism through a carbocation intermediate, with Zaitsev most stable alkene as major product, and aromatic stabilization can drive ring formation or conjugation. Moving on to the next step. The starting material is a tertiary benzylic alcohol where the OH-bearing carbon is at the ring junction of a partially saturated naphthalene system, at a position of an octahydronaphthalene, bearing an ethyl group. Specifically, it is 8A ethyl 3, 4, 4A, 5, 6, 7, 8, 8A octahydronaphthalene, 8A ol or equivalently a compound where a quaternary carbon bears O, ethyl, is part of a cyclohexane ring and is bonded to the ortho carbon of a benzene ring, making the carbon both tertiary and benzylic. Moving on to the next step. H2SO4 protonates the O. Water leaves to give a tertiary carbocation at the ring junction carbon. This carbocation is stabilized by the adjacent benzene ring, benzylic stabilization. And for the final step, the carbocation can lose a proton from the adjacent cyclohexane ring carbons, C8 or C4 positions, to form an alkene. Elimination toward the ring junction gives a double bond that is conjugated with the benzene ring, endocyclic, forming a dihydronaphthalene 1,2 dihydronaphthalene type, which is more stable than an exocyclic alkene. Alternatively, loss of a proton from the ethyl group gives an exocyclic alkene. Loss of a proton from the cyclohexane ring adjacent carbon forms a trisubstituted endocyclic double bond conjugated with the aromatic ring, giving 1-ethyl 3,4 dihydronaphthalene, or upon further consideration, the most stable product is 1-ethyl 1,2,3,4 tetrahydronaphthalene. But actually the elimination gives a double bond in the ring. The product, A, shows 1-ethyl 3,4 dihydronaphthalene, one aromatic ring fused with a ring containing one double bond, with ethyl at C1. This is the product of endocyclic elimination giving a vinylogous conjugated system. B, requires loss of the ethyl group or extensive rearrangement to give a naphthalene with propyl, unlikely. C, shows an exocyclic double bond, ethylidene substituent, which is less stable than the endocyclic conjugated alkene. D, shows a spiro or non-fused product inconsistent with the starting material connectivity. The major product is option A, 1-ethyl 3,4 dihydronaphthalene or 1-ethyl 1,2 dihydronaphthalene, formed by endocyclic elimination giving maximum conjugation with the benzene ring. Therefore, the correct answer is A. Therefore, the correct answer is option A.